Alrighty, so as you know, I am not here today because I am out of town at training. You have a couple different things you have to do today. So the first one is you should have already done your minute. You should have already gone over your minute, and now you're into your Edpuzzle for the day. So we are on Unit 7, Lesson 7, page 639. What page? 639. For all of you that don't remember what page it was, it's page 639. So on the first part is the which one doesn't belong. Remember, you can have any reason of why it doesn't belong. I'm going to label these 1, 2, 3, 4. So you will write the response of why it doesn't belong within the Edpuzzle. You'd say number blank doesn't belong because blank. Why doesn't it belong? On to the next activity. It says choose 6. However, in this video, we're only going to go over a couple. But in your Google form you'll get to after you watch this video, you will answer all of them. Because it's good practice for you. So you're not going to do number 2 because we're not skipping any of them. We're going to go over all of them. All of these are a review of the 3 rules we've done so far. We have the product rule, when you have 2 numbers being raised to a power and multiplied, which is where you add your exponents. You have the quotient rule, where you have an exponent being divided by an exponent, where you subtract your exponent. And we have the power of a power rule, where your powers are right next to each other, so you're going to multiply them. So if we were to look at this one right here, and we need to add our powers, we would have 2 to the power of 4 plus a negative 3. Well, 4 plus negative 3 is really 4 minus 3. So we have 2 to the power of 1. You can do the rest of them. The next one is the quotient rule, where we subtract our exponents. So if I'm looking down here at this, we're going to do this bottom one, where we're going to subtract our exponents. It's your numerator exponent minus your denominator. So we have 10 minus 12 minus a negative 20. Well, when you're subtracting a negative, it's the same as adding the opposite. So I'm going to go down here. So we have 10 minus 12 adding, and the opposite of negative 20 is positive 20. Negative 20 plus 20 is 8. So we have 10 to the power of 8. That's the answer to that one. The next one, we have the power of a power rule, which is where we multiply our exponents. So let's say I choose this one right here. I have 4 to the power of 3 times negative 3. Well, 3 times negative 3 is negative 9. So 4 to the power of negative 9. And this does not say it needs to be positive, so we can keep it as a negative exponent. You will eventually have to go through all of those. You will want to remember we have the product rule, which is adding your exponents. Quotient rule is subtracting your exponents. And power of a power is multiplying your exponents. Choose 3 of the following and write using a single positive exponent. So we've gone over this. I think it was lesson 5. Lesson 5. So when you have a negative exponent, it makes it into a really small number, and you would use the reciprocal. So if we're looking at this one right here, all of these can have a denominator of 1 right now. It does not change its value. When you have a negative exponent, you're going to use the reciprocal and a positive power. So you would flip it. We now have 1 over 2 to the power of 7. I'll do one more. Do this one over here. Using the reciprocal, you now have 1 over 2 to the power of 32. And that's what you would do with all of them. The next one's choose 3 to evaluate. So that means choose 3 to solve. Well, if we look at this one right here, we have 2/3 to the power of 3. Well, your power tells you how many times you write it. So we have 2/3 times 2/3 times 2/3. 2 times 2 is 4, times 2 is 8. 3 times 3 is 9, times 3 is 27. Oh, and remember, you're not doing 3 because you're going to be doing all of them. Alrighty, if we did one more, let's say we use this one. This is the product rule where we add our exponents. 8 plus a negative 8. Oops. Well, 8 minus 8 is 0. So we have 2 to the power of 0. Anything to the power of 0 is 1. So now you have those two done. You will need to solve the other ones. Mark each equation as true or false. What would you change about the false equation to make it true? So we have the product rule where our bases stay and our exponents are added. So is this a true statement? It is. 2 plus 4 is 6, and our 1/3 stay. Here we have different bases. So we would need to figure out exactly what it is. So we're going to write it out long ways because this one is false. So I'm just going to put it right here. We have 3 times 3 times 5 times 5 times 5. And I believe it was lesson 6. Where we can combine our other bases. Yes. So you have to find out how many of each there are. So we have 2 3s and we have 2 5s, and those match up. Giving us 3 to the power of 5 times 3 to the, times 5. And then we have 1 extra 5. So really we have 15 times 15 times 5. So we would rewrite this as 15 to the power of 2, because we have 2 of them, but then times 5, because we also have that. Next, we have 5 to the power of 4 plus 5 to the power of 5 equals 5 to the power of 9. When it's multiplying like this one up here, that would be a true statement. But it's not true, so we would just leave it as is of just that. If you want to expand it, you would have 5 times 5 times 5 times 5 plus 5 times 5 plus times 5 times 5 times 5. Alrighty. Next, we have 1/2 to the power of 4 times 10 to the power of 3. So we would rewrite this to see if this is true. We have 1/2, 1/2, 1/2, 1/2, 10, 10, 10. So half of 10 is 5. So I have a 5. Half of 10 is 5. I have another 5. And half of 10 is 5. One more 5. Times 1/2. So really I have 5 to the power of 3 times a half. or half times 5 to the power of 3. So this one was also false. All right, for this last one, we have 3 to the power of 2 times 5 to the power of 2 equals 15 squared. So this one is similar to this one and this one. However, our exponents are the same. So we have 3, 3, 5, 5. Those two can go together. Those two can go together, giving us 15 times 15, which is indeed 15 squared. So this one is true. Your homework is page 642. Everything. All of these have the same bases. So like this one doesn't have an exponent, but it's 1. Because remember, if it doesn't have one, it is 1. And that is same with this one right here. Doesn't have one, so it's 1. So you have your 3 different rules. You have the quotient rule, which is subtraction. You have the power of a power, which is multiplying. And you have the product rule, which is adding your exponents. Which you can do all 9 of those. Number 2, Noah says that 2 to the power of 4 times 3 to the power of 2 is 6 to the power of 6. Tyler says 2 to the power of 4 times 4 to the power of 2 is 16 squared. So let's see what we have. We have to figure out who you agree with and why not. My suggestion is to expand them both out and see which is true and who you agree with. So Noah's would be 2, 2, 2, 2, 3, 3. So those can go together and those can go together. And these would just be 2 squared. And then you have to figure out what is your 6, what power is your 6 to? 6 to what power? Do you agree that they would be the same? And then do the same thing with Tyler. After this video, you can either do your practice problems, turn them in first, or go and do the Google form and fill it out first. For the Google form, you will want like these pages because any work we did, because I'll list all the problems. You already have some of the answers, so it will help you a little bit. And that's it for today's lesson. Tomorrow's video will be on lesson 8.